I hope the screen is visible for you. Please let me know, anyone.
No, sir. No, no, sir.
Now check it.
Visible, sir, visible.
Okay, okay, fine. So in the previous class we have discussed regarding influence line diagram. So that influence line diagram is on considered with a concentrated load, which is static. So in this case, we had studied that the reaction how to takes place, how to calculate the reactions by taking the unit load on the support, and here it is important to keep in note that the influence line diagrams for particular stresses, the reaction stresses we can calculate with the diagram that we can observe in this window. And again we have another one, that is the reaction at support B, that we can have the influence line diagram with this, and taking the similar triangles we have to calculate reaction forces. And these all things we had already studied since it is 2-3 days before. So and that is why I would like to revise it now. The reaction forces are like this, and apart from, if you want to calculate the shear forces, the shear force is calculated at the section where it is to be given to calculate the positive shear force and negative shear force. And in the calculation we come to know that the maximum load, and in the total sum of maximum load that is considered on the right side of the section of your beam, if you consider, then the particular stress, that is shear stress, will be considered with a positive sign. And at the same time, if you consider the total load, maximum of total load, if you consider on the left side of the section of the beam, here with the example in the diagram we can see that will be a negative shear force. That is the sign we have considered as a sign convention for the negative as well as positive shear forces. And this is the point we need to keep in mind while considering the shear force at the section, right? And apart from that, we have another one is moment. Influence line diagram for the moment at a given point or a given section in the beam. So that is when the section, when the point on which we are going to calculate the bending moment, at that point we need to consider the apex point with the triangle, with a similar triangle. And here we need to remember this formula. So z into L minus z by z, and this is the function, or this is the formula that is most important to carry out throughout this calculation of influence line diagram, in calculation of moments at any section on the beam. So here we already discussed these things, how we have calculated this z into L minus z by z. This is already discussed. The same thing that has to revise, because we need to solve a more number of problems on this content. And this is what we had discussed as a brief for a stagnant or static load which is on the beam. And also we have discussed this problem. In this problem we have two loads, with one is uniformly distributed over the 6-meter span of the total beam, and we have another one concentrated load of 50 kilonewton. And this UDL load is to be considered under the influence line diagram. So I will just explain the diagrams over here, and then we can discuss with a new problem over here in this class. So here in this problem, to calculate the support reactions, we need to consider the support reaction for A. In the diagram is like this. What we know this, the diagram to calculate for the particular support reactions. So here in this support reaction we have a section C, and apart from we have another point load which is acting 2 meter from the right support, that is B, right? And that is what we have taken the section point over here. So if you take a point over here, so let me show with a marker here. So this is a unit load at the particular point. If it is a unit load, then what would be the coefficient value for a distance of 6 meter from the left end? a short time it will get open, and then I can use it. Yes. So now see, this is an triangle that is used to calculate, or that is referred to calculate the support reaction at A. Support reaction at A over here. So in this support reaction, if you consider, then there are the loads which are acting at the particular points on the beam, and those are considered with respect to the sections on the point which they are acting, on the point which they are acting. And at the case, if you consider it is an unit load, because at this point it is taken into unity, then it is a total span of 10 meter. Now if you consider this point, then we can consider a similar triangle over here. Or else for the for coefficient of this value, what will you do this? Here it is total span of 6 meter, 10 meter. In the 10 meter it is 6 meter over here, and remaining is 4 meter, and this 4 meter divided by 10, that is total span. So here if you consider 1 by 10, it will be considered, it is considered unity. That is, for this unity we are accepting, or we are targeting this point, and this point has the distance of 4 meter remaining. This distance has 4 meter remaining, and this 4 meter distance is considered to be the coefficient value for the total span, that is 4 by 10. This is, however, this is the regular practice to consider the coefficient values for the sections. Again over here it is 2, and this is 2. For this, we have 4 meter span, and for this support we have 2 meter span, and that is 2 by 10 will be a 0.2. At the same time, if you consider on the support reaction B, on B section, influence line diagram for B, here it will be a 1 unit load, and the section, if you transfer it to the same one over here, and here it is having a total of 8 meter span, and 8 by 10 will be of 0.8 coefficient value. And if you consider the section C at this point, and that section C has the distance of 6 meter from the left end, then that will be of 6 by 10, it is the coefficient value of 0.6. So this is how the sections are considered for the particular points. So in here, if you consider this one, here I have written that for x1, that is 1 by 10, that is taken, again it is a similar triangle, that is to be keep in mind by calculating the coefficient value, that is 1 by 10, and which is equal to x by 4, which is having the distance, and we can calculate the x by the with these functions. And again the remaining x3, x4, those value can be calculated by referring to the similar triangles on the diagrams. So once we know the diagrams over here, similar triangles, then we can able to calculate the shear forces. So how do we calculate them? By referring to the first one. So by referring to this diagram only, what I am highlighting, by referring to this diagram, just refer the diagram what is encircled in this, and 30, here is a 30 is a total load, that is uniformly distributed load, which is acting on the span of 6 meter. And whenever the UDL load is considered, that particular load is to be multiplied with the area of the influence line diagram. Since here we have a trapezoidal area, in this trapezoidal area we have the equation of height on the both side, that is taken average of these two heights, multiplying with the total distance of between these two. And that is what I hope that you people know, that what is the trapezoidal formula, right? Or else I could draw here and tell you. See, right, this is, if you consider one, the diagram, this is, say it is B and it is A, we will consider, and it is an edge, if you consider. So for the area for this trapezoidal, we could write here as A plus B, A plus B divided by 2 multiplying with the total height. That is what we have written over here. So here it is 1, here it is 1, and here 1 plus 0.4 divided by 2, 1 plus 0.4 by 2, and h we have 6. That is what here it is written. And remaining is 50 kilonewton load which is acting on the section 2 over here, which is acting, see, it is 50 kilonewton which is acting for this with the coefficient value of 0.2. So that is written as 50 into 0.2. So now again, if you consider this diagram for reaction at B, here it is a 50 into 0.8. That is again we have considered again that 30 kilonewton of uniformly distributed load which is acting on the area of triangle, this area having the height of 0.6 and the length of 6 meter, the half base into height with the intensity of load, plus we have an 50 into coefficient value of 0.8. Right, this is how we have already discussed this content, and this is the equation we need to consider while calculating the reaction forces. So now with this the shear force is again we need to consider in this format. At the same time, I hope it is remember let us discuss with a new problem that the uniformly distributed load is considered at this point. Again, the area under the load is taken into consideration, that is half base into height, and remaining 50 kilonewton with the coefficient value is considered. That means whenever we try to solve with the problems, the same procedure will be followed up. That is what my intention is to express over here. So now this is the second problem we can observe over here. It is been given that simply supported beam as shown below over here, and determine the support reaction, that is shear force and bending moment at the point C. I hope the whatever I have drawn and showing here, it is clearly visible for you. Right, so let us see, let us observe the questions what they have given. The simply supported beam is given with the 3 concentrated forces which are acting at distances respectively, and here they have asked to calculate the shear force and bending moment at the point C, which is 6 meter away from the left support, right, or we can say the 4 meter away from the right support. In the question they have given it is 6 meter away from the right support. So now, so here, if you want to calculate the support reaction, shear force, and bending moment, let us consider one by one. So support reaction, what it is exactly shown over here. So diagrams are need to be considered in a similar manner what we had learned right here. Again, if you consider it as a unity, so and that means we have to consider this as a unit one only. So 1 by the particular distance of the span, right? Whatever it may be, either 10 or any of the span, but what in the question it is given as a 10 meters, that is 3 plus 3 6 plus 2 plus 2, that is 10. So here if you have a section of load over here in these 3 points, you need to have coefficient for these values. So if you want to obtain the coefficient value for the particular, right, it is clearly visible now right now. So if you want to have coefficient value for this, again we need to consider a similar triangle. So how do you consider similar triangle? 1 by 10, which is equal to x1 divided by, this is 8 meter, 3 plus 3 plus 2, right? 3 plus 3 plus 2, that total will be of 8 meters from the section where we are considered. And apart from, we have another section, that is 6 kilonewton load, which is acting 5 meter from the support B. So how do you calculate that? 1 by 10, again the similar triangle we are observing. So I would like to draw over here the similar triangle. It is a triangle which is always referred for the remaining sections, right? So now for this, for first one it is referred this one, and for second one it is referred completely this one, and at the same time it is referred the third one. That means in the blue color what I have written, that is that we can write it by 1/10, right? 1/10, and it has x1 value of unknown. That x1 can be calculated with the base distance of, see, if in the 10 meter we have 2 meter over here and remaining will be of 8 meter, that is 8 it is written, and x1 will be of 0.8. And at the similar case, if you consider 1/10 for the same triangle, and remaining triangle, if you observe over here, which one is, that is marked with the pink color, that is x2. So x2 is the distance having 5 meter from the either supports, right? So this is 1/10, similar triangle we are observing 1/10 over here, and x2, that is the value of x2 over here. Those this value or coefficient value, if you want to calculate, we need to consider the triangle of this one, right? So in the similar triangle 1/10, and this height is unknown, that is x2, it is written divided by the span, that is remaining 5 meter for this triangle. For this triangle we have 10 meter span. For this pink color triangle we have 5 meter span. So 1/10 into, which is equal to x2 by 5. So in this equation we can able to calculate the value of x2. And at the similar case, x3 is there. Why we are considering x1, x2, x3 is because at this point, if you consider the section throughout the length, throughout the span, it will be like this. That means for these loads, we need to consider the value of coefficients. And apart from that, there is a C point. In this C point, they are asked to calculate the shear force and bending moments. For that reason also, we need to consider this section. We need to consider this section, which is 6 meter from the total left hand support, like this. I hope it is understanding to you people. So at the any time, if you have doubts, please let me know. Then I could clear you here itself. Don't keep it in your mind. Is it clear how we have considered this similar triangles and how we have calculated the coefficient values? Is that clear, dear students? Vinayak? Yes, Vinayak? So how many are there? Vinay?
Yes, sir.
Sorry, I'm asking you as a Vinay. Are you clear what I am discussing here?
Yes, sir.
Yes, remaining, I hope it is clear for you people. At least let me know that if you are clear. Or else at least let me know that if you are not clear and I could discuss here again. Don't sit quiet. Everyone, feel free to discuss. Nobody will talk to you anything. Just it is a matter of understanding only. Alright. So now again I would like to discuss the shear force, that is support reaction for B. So if you want to calculate the support reaction for B, again we need to consider the influence line for RB in this format. What I am showing with the cursor over here, that is the second diagram in this window. So here, if you consider support reaction for B, we need to have unit force at B section. So again, if you have unit force at B section, it would be having the coefficient values over here. That means the similar sections are to be considered. This is the section C, and this is the point load which is for 6 kilonewton, and this is the point load which is for 7 kilonewton. For these, the coefficient values are necessary. So again, I would like to have a similar triangle for this. So for this triangle, what it is showing with the blue color, it has the vertex height of 1 and the length of 10. It is known. And for this, we need the coefficient value for this section or this triangle. So how do you do that? That is, the height should be considered and the length is known. So here in the total length of 10 meter, it is 2 meter distance over here, and remaining is 8. So if you write that, for blue line, we have triangle of 1 by 10, right? And for pink line, we have the triangle of, that is x6, which is unknown because that is the height which is unknown, divided by 8. 8 is because in 10 meter it is, they were, subtracted with the 2, because here, from here we are starting to calculate the length. That means the pink color triangle has the base length of 8 meter and height is unknown. So this height can be calculated by referring to these similar triangles. So one triangle has, that is blue color triangle has 1 by 10, that is one height, and 10 meter length, 1 by 10. And again, if you consider the small triangle, the unknown height with the base length of 8 meter. So x6 will be of 0.8. And at the same time, if you consider, and this one, this section, that is for section C. So how do you calculate this? So here, and this total length of the span has 6 meter, correct? So in this total height 6 meter, again if you 1 by 10, that is similar because it won't change, and the triangle which we are considering with a height of unknown value divided by the span of 6, that you can have x1. So 1 by 10, which is equal to x by 6. So that x value will be of 0.6, what we have calculated. And similarly, if you consider the triangle of this one, so I could write with this diagram. So now for this, I can write over here, for large similar triangle 1 by 10 I am considering, which I am equating to the triangle which I need to get the value of x5. So x5 is the height of the considered triangle over here, and remaining, that is the length of 6 meter, that is, sorry, 5 meter. That means 3 plus 2, which is 5 meter over here for this span. So this is what we are considering. So x5 is 0.5. So that means by solving this, we'll be getting the x5 as 0.5. So that is the coefficient value for this one. And again, if you consider another triangle, that is over here, again I could take this I could take the green color one, right? For this triangle, if I write the equation, the larger triangle has 1 by 10, which I am equating to the triangle which is marked with a green color. So for that, x4 is the unknown value. X4 is the unknown value with the length of 2 meter at the base, because it has 2 meter over here. If you observe for this in the question, that is 2 meter. So that means x4 will be having 0.2 meter of, sorry, 0.2 as a coefficient value for this one, right? This is how we need to obtain the coefficient value for the triangles. I hope it is clear. With this, we'll need to write it for the reactions. So now, just observe over here and the diagrams in the circle 1, because this is the influence line for reaction at A. So the influence line for reaction at A is written like here. So how it is written? That's right here. See, just again I would like to draw these two, because we need the diagram for the load. Okay. So this is the total diagram that need to be considered for reaction of A, and this is the calculation what we had considered for RA. So now if you observe over here, if you observe here, it is 7 kilonewton has the coefficient value of 0.8. The same thing has multiplied 7 into 0.8 plus 6 into 0.5. It is the coefficient value 6 into 0.5. Again 5 into 0.2, which is here. That means the coefficient, that is the reaction support at A, having the force of 9.6. This is how we need to calculate. Again, if you consider the second diagram, which is shown in the color code over here, right? So if you observe the pink color code, here we need to calculate the support reaction at B. So support reaction at B, if you consider here, that is 5 kilonewton having the coefficient value of 0.8, which is written 5 into 0.8 plus 6 into 0.5, that is written, and again 7 into 0.2, that is the coefficient value is multiplied, then it is the total value of force as a reaction support B, right? This is how we need to calculate the support reaction for RA, that is support A and support B, right? So now this is about to calculate the support reactions. In the question they have now we have completed to calculate the support reactions. Now we need to calculate the shear force and the bending moment, right? For this shear force and bending moment, what we need to do is we need to have a shear force section. As we have already discussed that the shear force section is to be considered in this manner at the section where we are going to calculate the value. So this is the problem statement. In this problem statement, at the point C, if you observe the cursor I am showing, that point C, we need to calculate the shear force. So how we have calculated, how we have considered that point? That means here we have taken a section for the C. So what the section is, if you consider over here, this is the section what we have considered. So in this section we need to have shear force diagram. For this shear force diagram, it is been calculated, considered the similar triangles over here, like this, right? So in this similar triangle, the loads are acting with the particular distances. So those loads are to be considered, and which is for calculation for coefficient values. So how do you calculate, how do you consider this 7 kilonewton force, the point which need to extend over here, and again this 6 kilonewton which need to extend over here. Again, if you want to calculate the coefficient for this, so how do you calculate? At the same time, the similar coefficient, similar triangle that need to be considered. So 6 is the total span, and this is the 0.6. So how do you get this 0.6? So 0.6 is calculated by referring to 1 by 10. So 1 by 10, that is the total height, that is the total length what we had. 1 by 10 is a point, which one? That is the total length of the span, and this 0.6 is it is unknown because we need to calculate it before. So x I could take, and at the distance of how much? At the distance of 6 meter we need it, that is 6, that will be of 0.4, that is 0.6. So the 0.6 which we are considering at the left side, that is written in the downside, which is negative sign, which is 0.6 over here again. And at the same time, if you want to calculate this 0.4, that is similarly we have calculated 1 by 10, which is equal to x by the distance of this 4 meter, x by this distance of 4 meter. And once you consider the right side of the span, then that will be written in the positive sign, and that is nothing but the sign convention which we have considered, 0.4 over here. So x is equal to 0.4. So now once we know the coefficient value of these two, then with the similar triangle, we can now able to calculate the value of the remaining coefficients. So how do you calculate now? So now if you consider for this, and these values will be having this particular values. So how for here for this section, if you consider that 6 kilonewton load, will be having a 5 meter of span. So in the 5 meter of span, here it is a 5 meter. That means here we need to consider the similar triangle. So now for this, if I write 1 by, that is, it is not 1, that is 6 is the span, that is 6 by 0.6, which is equal to unknown, because this is unknown, divided by 5. That is the length of 5 meters. So how it is written, I hope you got it, right? That means here it is actually, it is span of 0.6. It should be written as in this manner. 0.6 divided by 6 with the height of that is height of unknown and the span of 5 meter. Then x will be of 0.5. So this is how we have considered this coefficient value. Again, if you consider this coefficient value, it has the triangle height of, that is 0.6 divided by 6. Because why I am considering 0.6 by 6 is because this is the height, length of 6, and this is the height of 0.6. And for this larger triangle, I am considering this section. So this section has 2 meter span. So in this 2 meter span, the height need to be calculated. So height is unknown, the span is 2 meter at this triangle. So if you calculate this equation, then x will be of 0.2, and it is written negative sign because it is taken in the downside. So this is how we have to calculate the supports, and that is coefficients. And again, if you consider in this part, and this is having the 0.2, how it is calculated? It is calculated with the distance of the total span. In this total span, it has 2 meter and it has 3 meter. In the question it is given, it is 3 meter and it is 2 meter. 3 plus 3 and 2 plus 2, it is 10. In this total 10, we have the 6 meter of up to here. Up to here we have 6 meter of span. So in this, if you observe question over here, it is like this. It is like this. And that means to up to section 6 kilonewton, it has 5 and the remaining is 5. And that is what it is written like this. So for this, we have an triangle of this one, that is the larger triangle. And for this larger triangle, we need to consider the height. So how it is considered? Previously we have discussed that total 1 by 10 we have, and for this, that is x is unknown with the length of 4, because this is the remaining length. This value is unknown. So with this, the x can be calculated as 0.4. So that is written. So if you have this value as a 0.4, then how do you calculate this 0.2 with a similar triangle? So similar triangle means this triangle need to be compared to this larger one, that is denoted in blue color. So now if you write for that, so how it will be 0.4 divided by 4, which is equal to x, because this is unknown, this value is now we are calculating, divided by 2, because it has the base length of 2 meter, right? This with this x we can calculate, with this equation x can be calculated as 0.2. So this is how the coefficients are calculated. So if you calculate these coefficients, then it is the time to calculate now the shear force. So how it is calculated? Just multiplying the coefficient values with the concentrated forces. So 7 into 0.2, which is minus sign, 7 into minus 0.2, and again 6 into 0.5 coefficient value, and 0.2, which is this one, into 5, 0.2 into 5, or else 5 into 0.2, which is positive sign, and the remaining these two has negative sign. You will be getting minus 3.4 kilonewtons, which is negative shear force. Why we are getting this as a negative shear force is because on the left hand side we have taken the maximum. On the left hand side we have taken maximum loads, that is why we have got it as a negative force. If you have a maximum force of the on the beam on the right side of the section, then it would be of the positive shear force. Nothing will change the in the number of value of shear force, only the sign convention will be changed. So after this is more than enough what we have calculated the shear force. Now it is time to calculate the bending moment at the given point, because it is asked over here. Support reaction we have calculated, the shear force we have calculated. Now the bending moment need to be calculated. So here, to calculate the bending moment at the section, the question is considered in this manner. This is the question. In this question, the value of the point C, at this point C we need to calculate the total bending moment. So in this bending moment, how it is at this point, how it is calculated the bending moment? Again, taken the influence line for movement, influence line for the movement. So in this influence line for movement, how it is calculated? For 0.7, and that means the 0.2, which is calculated the coefficient values of similar triangle, and again 0.5, like this. So just I will explain how the coefficients are calculated. So whenever we are going to calculate for a particular height, a particular section, the most important thing that has to be remembered. Now this is the triangle. So this 0.6 how we have obtained is total 1 by 10, total span is 10 meter, right? So in this total span 1 by 10, and at this point we have total span of 6 meter, which is unknown, again which is unknown. So x by 0.6, so x by 6 meter. So x will be of 0.6, like this. So now if you got the apex, that is coefficient value for this line as a 0.6, now it is time to calculate the remaining points. Again it is nothing but taking similar triangles at this point. And again if you consider another one, that is a similar triangle like this. Again now if you consider, this is, I hope the color code is differentiating the triangles which we are calculating. So for this the span of 5, right, and for this the span is 2 meter. That is why it is 0.2 and it is 0.5, and for this it is the span of 3. So how much it is calculated? So in this manner it is being calculated the coefficient values. So once the coefficient values are calculated, then it is simple to calculate the moment. So multiplying the load into the coefficient value, 7 into 0.2 plus, that is, you can say 5 into, that is 6 into 0.5 plus 5 into 0.3, and total will be of 5.9 kilonewton meters. So this is how we need to calculate the bending moment values for the given loads and the shear force for the given loads with the influence line diagram and the support reactions. Dear students, is that clear? If you have any doubts regarding this, you can ask me. So however you people are joining for the classes, and if you sit quiet, even having doubts, it is not good. It's completely waste. Yes. Because these are the very basic problems, and I guarantee tell you that there will be a question on this concept in your external exams. That too for 12 to 15 marks. That too for a maximum of 50% to 60% of total module weightage is to be considered for these problems. I hope the problems are clear for you, and let us have another problem that is given here, that is the shear forces at the section of the point G. Only the shear force has to be calculated for this G. In this problem, they have asked to calculate only shear force, no support reactions and no bending moments. Find shear force at section G for the loaded beam, that is simply supported beam, that too using the influence line diagram. Also find the shear force in all sections. So first we need to find out the value of G, that is shear force at the point of G, and after that we need to calculate the shear force in all the sections. That is what they have asked in the question. So here again the shear force diagram is shown over here. I hope now it is clearly visible. So at this section we need to have the shear force. So to calculate the shear force, again we need the value of coefficients at the sections where we are considering. So now this 0.475 is calculated by referring to the total span. The total span has a 20 meter, right? And for this section G, what is the total length that is remained on the left side, that is right side? The right side value is taken to the positive and left side value is taken to the negative. It is the same convention which is following in the influence line diagram. So now in this 20 meter, this 2.5 is the plus 3, that is 5.5, plus 4, that is 9.5. So that is the total 9.5 length is there. So in this 9.5 divided by total span of 20, that will be of 0.475 of the coefficient value. And at the same time we need to consider similar triangles. So this is the triangle which we have calculated, and at the same time we have to consider this one. So here the total span will be how much? 3 plus 4, which is 7 meter. So how do you calculate here? Again it is 7 by, so how much it is? It is 20. See, you people have to interact. If you sit quiet, you won't get 7 by 20. So that will be of 0.35. Right? So now again it is similarly you need to calculate this one. So how much it is? It is 4 meter. It has 4 meter. So in this 4 meter, how it is calculated? This value, that is That means again similar triangle it is observed. 9.5 divided by 20 and unknown by 4. So how it will be getting? Sorry, it should be written value of 0.475. 0.475. That means similar triangle that need to be have. And here it is total span of 9.5. So 0.475 divided by 9.5, which is having the equating to 4 meter, and the x value will be of 0.2. X value will be of 0.2. So this is how the x value is obtained, and at the same time here it is also calculated. So how it is calculated at this point? The point G, that is at this point the total length has 10.5. In the total span it is remained with 10.5 when it is considered 9.5 on the right side, and remaining is 10.5. In this 10.5 we have total length of 20, and 10.5 by 20 will be of 0.525. So that means we need to consider the point at this location, that is coefficient at this location for the total span. So 0.525. So if you consider this as a larger triangle and this as a smaller triangle, that I could write for this equation, that is and 0.525 divided by 10.5, which has a similar triangle, the unknown height of x divided by the total span. How much it is? Here it is 8 meter. That means the base of this height of this triangle is 8 meter, like this. So now the x value will be of 0.4, and since it is taken at the downside, which is negative, and this is positive, and that is why it is taken with the negative sign. So this is how the coefficient values are to be calculated. So now, so for this the shear force value that need to be calculated by referring to coefficient values and loads respectively. So how do you calculate the loads and coefficient values? Just here observe, this 5 kilonewton load into minus 0.4 is the coefficient value. 5 into minus 0.4 plus this 15 into 0.35, and next this 15 into 0.2. So altogether if you add with the same considerations, it will be of 6.25 kilonewton of shear force at the section G, right? Because with respect to section G we have considered the coefficient values and we have multiplied with the intensity of load, right? In the similar manner we need to consider the remaining sections, because in the question they have asked also find the shear forces in all the sections. So now the shear force at G is calculated and the coefficient values are calculated, and at the same time the particular values of the different sections that need to be calculated. So here please everyone, I would like to ask you people, take the screenshot of this one, what exactly the window is showing. Take the screenshot of this one, and once that screenshot is taken, that can be referred for the different sections to calculate the coefficient values and to calculate the shear forces. I hope and it is clear for you. The whatever the section is drawn over here,
Yes, sir. We are getting it.
right, and the section is drawn over here, that is for the shear force at section G. And the similar section if you want to calculate at C, then the shear force diagram line will be at this point, as you can see here, like this. And the coefficient values need to be considered with a similar triangle, and the loads are to be multiplied. And again, the shear force at D, if you want to calculate, then shear force will be like this, the coefficient values. Then again, the load values need to be multiplied with the coefficient values. And at the same time, at the point E, if you want to consider the, again with the similar triangles, we need to calculate the coefficient values, and then we need to multiply those coefficient values with the intensity of load at that particular point. And with, if you do that, then the total shear force at that considered section is obtained. Right? I hope it is clear for you what it is discussed in this class today.
Yes, sir.
Okay, thank you very much. And remaining remaining I hope everyone it is clear what we have discussed today. Aishwarya, all of you, I hope all of you are listening the class. Okay. With this, I will conclude this class. In coming class, I would like to discuss with the moving loads. With the moving loads, and this is more than enough to calculate or to discuss the shear force, support reaction, and bending moment for the given loads. Only thing is we need to consider the section coefficient values at the particular points where we are going to calculate. If you do that, that will be more than enough. So after this class, I will share this PDF in your WhatsApp. Please go through that and clarify your doubts through the notes. If you still have doubts, if you are not clarified, you can contact me with a phone call or the WhatsApp. Right. So with this note, I will can conclude this class. In coming class, by tomorrow, I will start with the moving loads. I will start with the moving loads, which are considered for calculation of different kinds of stresses. That is bending stress as well as shear stresses. Right. Thank you everyone for attending the class.
Thank you, sir.
Okay. Thank you everyone. We can leave now.